Hello students, in this video we'll discuss how to solve non-homogeneous constant coefficient ordinary differential equations. To solve a non-homogeneous constant coefficient ODE, we find an operator which annihilates the non-homogeneous term. To turn our non-homogeneous ODE into a homogeneous ODE, then we plug back in and check. Once we've solved. Let's see an example of this to get our hands onto a problem. Let's solve y double prime minus y, a constant coefficient ODE expression, equals e to the x. Following our idea, we need to find an operator that annihilates e to the x. We note d minus 1 applied to e to the x is 0 by our essential ODE. So we will apply d minus 1 to both sides of the equation. When we do so, the left-hand side will become d minus 1 applied to d squared minus 1 y, and the right-hand side will be d minus 1 applied to e to the x. Now we notice that d minus 1 applied to e to the x is 0, and we've turned our problem into a homogeneous ODE. Now we can continue the factorization, so d minus 1 d squared minus 1 y equals 0 is equivalent to d minus 1 squared d plus 1 y equals 0, or by flipping the order of these operators, equivalent to d plus 1 d minus 1 squared y equals 0. Now we focus in on the terms that we can solve. By our essential ODE and our repeated ODE results, we know that the solution to this box is c1 e to the negative x, and the solution to this box is c2 e to the x plus c3 x e to the x, which tells us that the solution to the homogeneous ODE is y equals c1 e to the negative x plus c2 e to the x plus c3x e to the x. But notice that we started with a second order ODE, so we should only get 2 arbitrary constants in our solution, but we have 3. So we need to plug back in and check. Notice that when I plug in either of these first 2 terms into the original equation, y double prime minus y will annihilate both of these terms, so these terms will vanish in the original equation. So all we need to plug in and check is this c3x e to the x term. So this is our y. Y prime will be c3x e to the x plus c3 e to the x by the product rule. And then doing the derivative one more time, this will be c3 x e to the x plus c3 e to the x plus c3 e to the x. And now it must be the case that y double prime minus y is equal to e to the x. Y double prime minus y will be c3x e to the x plus 2c3 e to the x minus y, which is c3x e to the x. These terms will cancel, and I'm left with y double prime minus y being twice c3 e to the x. But the equation tells me that it has to be equal to e to the x, which tells me that 2c3 has to be equal to 1. Therefore, the coefficient c3, which was originally thought to be arbitrary, must actually be 1/2. Now we can update our solution. Our solution is y equals c1 e to the negative x plus c2 e to the x plus c3, which we found to be 1/2 x e to the x, and we arrive at our solution. So, to summarize, in order to solve non-homogeneous constant coefficient ODEs, we annihilate the right-hand side, we plug back in and check to make sure that we have the right number of constants. Thank you very much.